Hello, this is Mrs. Shuver, and today we're going to discuss decimal operation rules. And operation in math is talking about the adding, subtracting, multiplying, and dividing numbers. There's also an operation called exponents, which we'll deal with later. So operations mean in math what we do or what we perform on numbers. So each time we use a different operation, there's usually a new rule for that operation. And the reason we're doing this with decimals is because this is going to transfer over for what we're doing on our next unit called integers, another set of our family of numbers. So let's start with our first operation of addition. So when we add numbers that have decimals in them, the most important rule is that we have to line up the decimal points. So I'm going to take 28 and 37 hundredths, the operation of addition, and now comes the important part. I have to line up the decimal points. So I choose to write the decimal first, then I put what is behind it, and then I put what is in front of it. That's just what helps my mind. You're going to notice that there's nothing below this 7. So oftentimes we put what's called a placement 0. I sometimes refer to it as a ghost 0. And then you're going to notice that everything is lined up in a column. So we not only line up the decimal points, but we line up the place values. For instance, this place value is the ones, this is the tenths, this is the hundredths. So now I'm going to add in those columns. I want to drop down to my decimal. I usually do it right when I come to it. Some people save it for the end. It's better for me if I do it right when I see it. I had to carry, by the way, 3 plus 9 was 12, and I didn't show my carrying. So 1 plus 8 plus 5 is 14. I'm going to carry it, so carry that 1 again, and now the final answer should be 34 and 27 hundredths. The most important part, again, is lining up these decimals. Right here is what our rule is. We need to line up the decimals and the place values. Our next operation is subtraction. And the most important rule is that we still have to line up those decimals. However, there is another important rule. When we're subtracting, order does matter. So even though this 6 and 3/10 looks smaller than the other number, we still have to use it. It comes first. We cannot reverse the numbers when we work with subtraction. So now the decimal rules, I have to keep the decimals lined up. So I'm going to write what's behind the decimal in this number, and I'm going to write what's in front of the decimal in this number, and I'm subtracting. So this looks really odd. However, if we put a placement or a ghost 0, that's going to help us. Now we have all the place values lined up and decimal. So when I start from right to left, when I subtract 0, take away 5, I can't do. So I'm going to have to borrow from this 3, and I'm going to borrow 10, and so I have 10 minus 5, which is 5. Now I have 2 minus 4. Again, 2 is smaller than 4, so I'm going to have to borrow from my 6. And I have 12 minus 4, which is 8. Again, it's helpful for me if I drop down that decimal right away. 5 minus 2, and the answer is 3 and 85 hundredths. The next operation we're going to deal with is multiplying. And this one, even though these numbers are, because they're both, I see 2 digits with the decimal in the middle, these numbers the decimal will line up, but that's not the most important rule. The most important rule is that the product, which means the answer after I've multiplied, has the same number of digits behind the decimal as what I see in the factors. And the factors are numbers that I'm working with. So I'm working with this number and this number. However, I notice that there's 1 number behind the decimal and 2 numbers total behind the decimal. So that tells me that I should have 2 digits behind the decimal in this particular problem. So 2 digits behind the decimal in my answer. And again, the answer is called the product. And just to clarify, if I had a number like this, I'm just going to make up a number right now, and I was multiplying it times this number, then I would count 1, 2, 3, 4 digits that are behind the decimal, and I'd have to do 4 digits behind the decimal in my answer, or the product. Now, because we know we're going to do that, and we tried to do that ahead of time, when I multiply, I really don't even have to pay attention to the decimals. In fact, I was taught, and this is my preferred way, but you may do this differently, I can just, when I'm multiplying, not even use the decimals. I really have to know, though, and I have 2 digits, I'm going to have that in my answer. But if that makes you uncomfortable, you could go ahead and show them. And then the factors, or these 2 numbers that I've chosen, you notice they do line up, but that won't always happen. So 8 times 6 is 48. Carry the 4. 8 times 4 is 32, plus 4 more is 36. And now I'm done with this number. Since I'm moving over to the 5, now I need to scoot over. I'm going to put a placement 0, and I'm going to scoot over and put my first number underneath the 6. 5 times 6, 5 times that 6 is 30. I have to carry that 3 from the 30. 5 times 4 is 20, plus 3 more is 23. Oops, kind of a weird looking 3. And now I'm going to add these together. 8, 6, 6, and 2. Now, this is when this rule comes into play. I need 2 digits behind the decimal point. So right now the decimal is here normally. If I don't see it, it's behind the number, and I need to have 1 number, 2 numbers behind the decimal rather. So the answer, known as a product when we multiply, is 26 and 68/100. Okay, our final operation coming up. All right, many people feel like division is perhaps the hardest of the operations, and you can see that's what we're working with here. So when we divide, just like subtracting, order really matters. So I have to use this number, and it's going to go in the house. Sometimes you might have heard the phrase top dog gets the house, or first dog gets the house. And what that means is I'm going to put that inside the division box, which means that this number goes outside. So whether I have decimals or not, this is how we set up a division problem. First number or top number gets the house, goes inside the box, and whatever it's dividing into that number goes outside. So now here comes the decimal rule. I cannot have a decimal in the number outside the house. The number outside the house is called the divisor. So if I look at this number, sure enough, there's a decimal in that number, and I cannot have a decimal in my divisor, or the number outside the house. So what I'm going to do is I'm going to scoop it so it's now here. So it was 2/10, and now since I scooped it past the 2, I now have 2. So that's legal, meaning I can do that in math as long as I balance it by doing exactly the same thing inside the house. So since I scooped this 1 scoop, I have to scoop this 1 scoop. So now the decimal is here. So the number inside the house is now 79.6. And now I want to bring that decimal up. It's going to stay there. It's stuck there. And I'm going to start my division process. And so when I divide, because it is a tougher operation, I'm just going to have you focus right now on the 7. I want you to pretend there's nothing else on the paper but that 7. How many groups of 2 could I have in order to get close to 7? So 2, 4, 6, I'm making 3 groups to get to 6. And if I have 4 groups, I'm going to go to 8, and that's too much. So I was able to make 3 groups of 2. And I said 6, but so there's 3 times 2, 3 groups of 2 make 6, and so now I'm going to subtract 6, which leaves 1, and I'm going to continue to divide. So I'm going to just drop this number that's left over, just the 9. I'm going to drop that number down, and I'm going to pretend that this is 19. And that's all I'm going to look at right now. So how many groups of 2 will go into 19? 2, 4, 6, 8, 10, 12, 14, 16, 18. And that took me 9 2s when I skipped counting, but I only got to 18. I don't want to go over, so 9 times 2 is 18. So I'm going to take away 18, and I have 1 left over. So now I notice I have this 6. I'm just skipping. I'm not even looking at the decimal. I'm going to drop down 6 all the way down, and I have 16. So now I need to know how many groups of 2 will go into 16. So I'm going to skip count on my hands. 2, 4, 6, 8, 10, 12, 14, 16. I have 8 groups of 2. And the good news is it's exactly 16, and so I'm done. So the answer, which is called a quotient when we divide, is 39 8/10. So to recap, the most important point is I cannot have a decimal in my number outside the house. That number is known as a divisor. So I'm going to have to scoop the decimal so that it's past, or until I don't have any decimal places behind. I don't have any numbers behind the decimal, and I have to do exactly that same number of scoops inside the house. So I hope this was a helpful review, and I will see you next time we meet.